Hello everyone, good morning to those of you watching this video this morning. In this series, we will learn about Boyle's law. To understand this concept, we present a cylindrical vessel, where the top of the vessel is connected to a piston. This piston can move up and down. This way, the volume of the airspace inside the cylinder can change. The air column will be filled with an ideal gas. Assume the vessel is leak-free, so the number of ideal gas particles in the air column remains unchanged. The number of moles of ideal gas remains constant, and the mass of the ideal gas remains constant. There's another additional tool, a thermometer. We can place the thermometer on one side of the vessel. In Boyle's experiment, we will maintain a constant temperature of the ideal gas. Let's call it T0. And a pressure gauge on the other side. It seems all the equipment is assembled. Before conducting the experiment, we will observe the initial conditions. Of course, there is a weight above the piston. This weight exerts a downward force. A force acting perpendicular to a surface exerts pressure. In reality, that force could come from a motor. The pressure is P0. The piston compresses the gas with a pressure of P0. Remember, pressure in a closed space is transmitted equally in all directions. Therefore, all parts of an ideal gas experience the same pressure of P0. The initial volume of the gas is V0, which is simply the volume of the air column inside the vessel. As a starting point, when the gas pressure is P0, the volume of the gas is V0. We can begin the experiment. In the first experiment, we'll add a weight above the piston. Naturally, the piston moves downward, compressing the ideal gas. The additional weight increases the gas pressure to twice the original pressure. This means the gas experiences an increase in pressure. The volume of the ideal gas decreases to half of V0. When we apply additional pressure to the piston, it triples the original pressure. The piston moves even further downward. The volume of the ideal gas changes to 1/3 of its original pressure. Now, we remove some weights from the piston so that the pressure decreases to half its original pressure. The piston's volume increases to twice its original volume. We can record the data we've obtained in a table. One column contains the gas pressure. One column contains the volume of gas. And another column. Multiply each value in the same row. The result of the multiplication is the same, P0 times V0. If we replace each value with an index, we get the following equation. P1V1 equals P2V2, which equals P3V3. This mathematical expression can be simplified to PV is constant. This is the mathematical form of Boyle's law. This equation was first stated by Robert Boyle in 1966. In simple terms, if the temperature of a gas in a closed vessel is kept constant, then the gas pressure is inversely proportional to its volume. We hope this tutorial is helpful. And don't forget to watch the next video.